Well, good afternoon and welcome to the Idahoan Show. As you may or may not be aware, in the 1950s, Gunter Voss, working at that time for the CETME Corporation, developed a very special projectile for their 7.92 by 41 millimeter CETME cartridge. It consisted of a very long aluminum projectile with a heavy copper band around its middle. The idea here was that by using aluminum instead of lead for the core of the bullet, you'd get a much longer bullet for the same bullet weight. And a longer bullet can be made much more aerodynamic, assuming it flies stably. However, stabilizing a very long aluminum projectile is rather difficult, and so the copper band served two functions. First, it provided a better surface of engagement between the bullet and the rifling and the bore, but perhaps more importantly, because copper is denser than aluminum, it helped to distribute the mass of the bullet more towards its periphery, increasing the moment of inertia of the bullet, and thereby increasing the effectiveness of spin stabilization. Now, from what I understand, the CETME bullet concept basically worked in a technical sense, but it never really caught on commercially. And I can kind of see why. I mean, putting it in the context of more familiar rifle calibers, if you have a .308 rifle and you have an application that requires better performance at extended range than what your .308 is capable of with normal ammunition, are you better off trying to get some kind of exotic bullet design that will extend the range of your .308, or are you better off just picking up a 300 Win Mag that will deliver the knockdown power you need at extended ranges? So I can see why that may not have gone anywhere commercially as a rifle cartridge. However, it occurred to me that it might be a very practical concept when it comes to shotgun projectile design. Because most existing shotgun slugs have a pretty abysmal ballistic coefficient. And they kind of have to, because if you make a lead bullet the diameter of a 12-gauge bore, it has to be pretty short and fat, otherwise it'll be excessively heavy. But if you apply the CETME concept and make an aluminum bullet with a copper band, you might be able to come up with something that's a little bit more aerodynamic and still has an appropriate weight. I started by turning the aluminum core of the projectiles on my lathe. Next, I put a piece of copper tubing in the lathe and parted off rifling bands. The diameter of the tubing was just a little bit too large, so I made a simple swaging die that I could pound the rifling bands through to swage them down to the correct diameter. Then I pressed a rifling band onto each projectile and proceeded to load them into shells. So as you can see, this is a reasonably aerodynamic shape, certainly much more streamlined than your typical shotgun slug, and yet it comes in at a weight of about 7/8 of an ounce, which is perfect for a high-velocity shotgun load. Actually, the copper band represents about half of the overall weight of the bullet, so that bodes well for stability. Anyway, let's go ahead and put a few of these downrange and see what happens. Okay, so we've got about a 4-inch group overall. I'd say that's on par with a lot of commercial shotgun slugs. They're all nice round holes. I don't see any keyholing going on, so we appear to have good stability. And out of a 7-shot group, we have 3 rounds that are almost in the same hole. Now, when I machined these, I machined them by hand, and there were some variables or dimensions that I may not have controlled real precisely from one projectile to the next. So I suspect that if I was able to use a CNC machine to automate the process and improve the consistency of the projectiles, we'd probably start to see most of them grouping in this hole instead of the overall group that we're seeing. That, of course, is just speculation at this point. But overall, I think this is definitely a promising design. Let's shoot a frozen milk jug with it and see what happens. Well, the ice is very solid this time of year, but I didn't have any trouble hitting the jug, a couple of times in fact, and the slugs did a fair amount of damage, although it doesn't look like either of them made it all the way through. They were stopped by the ice. Now, I did find an aluminum core perfectly intact, embedded in the pile of ice where I picked up the target. And I also found, a little ways away, this shred of copper, from the copper band. So it almost looks like maybe the aluminum core went into the ice, and then the edge of the copper band hit it and expanded kind of like a hollow point and actually tore itself to pieces, sort of fragmented as the projectile was entering the target. So I don't know what to make of that. Certainly, this thing seems to have some interesting terminal ballistics, but I don't really have the equipment to investigate those in more detail at this time. Next, why don't we take just a couple of shots at a 100-yard target, just to see what we can see. I don't really have enough rounds to do a proper study of long-range accuracy at this time, but we can still throw a few down at the 100-yard target and see what we see. Okay, well, this target has been used for other things in the past, and so it's already got a bunch of holes from rifle fire, but you can clearly see a brand new 12-gauge hole right about in the center of the screen there. So that one is accounted for. The other shot I don't see anywhere on paper. I'm guessing it went high and made that hole in the snow up there, but that hole may have already been there from other tests. I'm not really sure. So, at any rate, 1 out of 2 on paper at 100 yards is really not bad accuracy from a 12-gauge shotgun slug. Again, I'd need more than 2 rounds to do a proper study of long-range accuracy. And last but not least, let's see if we can get a chronograph reading on one of these. Now, I didn't make enough of these to really experiment with different loads, so I just selected 20 grains of 700X powder as my starting load, and that's what we've been testing here today. Not saying that that's necessarily the best or the most powerful load that these could be used with, but it provided a starting point. So let's shoot 1 or 2 of these across the chronograph and see if we can get a reading. That one came in at 1,128 feet per second. And that one came in at 1,177 feet per second. So it looks like with this load, the slugs are leaving the barrel supersonic, but just barely. I suspect they could probably be loaded to significantly higher velocities than that. But again, on this first try, I didn't make enough slugs to really do any serious load development, much less long-range testing. They are a bit tedious to make on manual machine tools, as I've been doing. Nevertheless, this is definitely my most successful shotgun slug design to date, and I think it definitely warrants further development, so when and if I get around to doing that, it will be interesting to see how far I can develop this concept. But anyway, until next time, thank you for watching The Idahoan Show.